Afternoon, everybody. This particular problem, I think, is a GMAT preparation problem, and it reads, if a two-digit positive integer has its digits reversed, the resulting integer differs from the original by 27. How much do the two digits differ? And already you have some ambiguity right here. Now, I know sometimes it's kind of hard. If you word it perfectly, it confuses more people, but this right here is a naturally ambiguous statement. By how much do the two digits differ? Let's say A and B were the digits. You could either be meaning A minus B or B minus A, right? Now those two numbers are just going to differ by a sign. But again, this could either mean A minus B, right? If A is, say, the tens digit and this is the units digit, or it could mean B minus A. Now, there may be some kind of convention they use to resolve this, but again, it's naturally confusing to just say how much do the digits differ, okay? And again, a concrete example here would be like if this were 5 and this were 3, 5 minus 3 is 2, but 3 minus 5 is minus 2, right? So, you know, technically you might want to say the absolute value, the difference of the two digits. So anyway, that kind of thing creates confusion. Hopefully the test graders would take either answer, I guess. But anyway, let's look at just a kind of an example here. Let's say we're talking about the numbers 62. Okay. Now, if you reverse the digits of 62, you get 26, right? All right. But to solve this problem, you actually, and you can see right off that these differ by 36, right? But to solve it mathematically, it's more useful to write it like this: 6 times 10 plus 2. And this is just called the expanded form, folks, the expanded form. This position right here is called the tens position. This is the units position. And right here, this would be 2 times 10. 2 times 10 plus 6, right? Now, it's real evident that these differ by 36 reading from left to right. All right, and maybe that's the convention that they're using, but in any event, it's not a big deal. But you know, if I was a test taker looking at this, I would go, what do you want, the positive or the negative? Because this guy right here is always going to be the negative or the opposite of this value right here. Now, but as far as just working the problem, I think what they wanted is this. If you let this be the original number right here, this is the well, I guess it doesn't make any difference, but I guess you could make this one the original number. But in any event, the digits are reversed right here. Okay, the digits are reversed. All right, and so you see you get 20, just by reading the problem that we want that value to be 27. Okay, and so if you carry out the arithmetic here, A minus 10A would give you minus 9A. 10B minus B gives you 9B. And then if you take 9 out of this, you get 9 times B minus A is equal to 27. And of course, that gives the difference of 3, which is the answer they were looking for. And that gives it. But again, the order that this is presented is sometimes confusing, in my opinion. And also, note whether or not you agree with the way I stated this, you could, when it says how much do the two digits differ, the answer here could actually be B minus A is equal to 3, or A minus B would be equal to -3. Okay. Okay, not a super big deal, but just like I say, sometimes if you word it, go to the trouble to try to word it, it's a lot clunkier. Like you would have to say something like, how much does the absolute value of the difference differ, or something like that, and that gets clunkier. People may be confused about absolute value and so on and so forth. So I understand for the need for brief instructions, but in my opinion, these instructions are just inherently ambiguous.